Greetings YouTubers, it's Rick the Tech Enthusiast again with the next Elegoo lesson number 3, LED. In the last lesson, we just used the Arduino UNO R3 board, but this time we're going to need the following items from your kit: the Arduino UNO R3 board, a 5mm red LED, a 220 ohm resistor, a 1K ohm resistor, a 10K ohm resistor, 2 male-to-male wire jumpers, and the breadboard. I'll also use a 10K ohm potentiometer. Yours may come like this with the potentiometer and the turn knob separated. Simply insert the small hex end into the potentiometer's hole to finish the assembly. In this lesson, we're going to learn how to change the brightness of an LED by using different values of resistors. So let's get started. Now the guide will go into detail about the breadboards, but simply it's a plastic block with holes. Inside the block are strips of metal to make various connections. The top and bottom rows are all connected together and they run the entire length of the board and are typically used for power or ground bars. All the holes in the middle, each little row, or I guess column in this case, is connected together. So any wires or devices in a single row are all electrically connected together. The guide also goes into detail about LEDs and resistors. I encourage you to go check it out, but simply LEDs will light up if connected correctly, and they are usually protected by a resistor. A resistor resists the current flow, thereby reducing it. Also, the positive leg of an LED is usually the longer leg, or a longer lead. So if you check out page 47 in the guide, you'll see we're going to use the 5-volt supply on the UNO to light up the LED with a resistor in series. We're not going to be programming anything this time. It's just going to use a UNO using your USB power supply. We're going to change out that resistor and see how it affects the LED's brightness. Lastly, I'm going to add a potentiometer so you can vary the resistor in real time. Page 48 shows you a diagram, and this is how it looks when it's all hooked up. Here's the completed circuit with a 220 ohm resistor in series. Notice how bright the LED is. Here's a view from a different angle. I swapped out the resistor for a 1K resistor. Now notice how the LED is slightly dimmer. Here's another view from a different angle. Lastly, I put in the 10K resistor. Notice how dim the LED is now. And again, here's another view from a different angle. So as a bonus, kinda, I've changed the circuit to look like this. Now there's a 10K potentiometer in series with a 220 ohm resistor and the LED. The potentiometer allows us to vary the resistance from nearly 0 to 10K. That way we can adjust the brightness in real time. The 220 ohm resistor keeps us from burning up the LED. Here's a close-up of the finished circuit. Notice I connected the 220 ohm resistor to just one of the legs of the potentiometer. The middle lead, or the wiper, located in the back of the potentiometer, is jumpered to the LED. The rest of the circuit is connected as before. So you see, I can adjust the brightness of the LED from very dim back to very bright. I measured across the LED and got a reading around 2 volts. This is commonly called the LED voltage drop, or the forward voltage V sub F if you were getting it from a data sheet. If we subtract the total voltage by the LED's voltage drop, then we can calculate the voltage across the resistor. Since amps equals volts divided by ohms, we can determine that the current flow through the circuit is about 13.6 milliamps. Typically, the maximum forward current for this LED is 20 milliamps, and don't exceed 25 milliamps or you'll let out the magic smoke. Well, that's it for Lesson 3, LED. In the tutorial, there's additional information on the resistor coding and LED and breadboards, so I encourage you to check that out. The next lesson will be Lesson 4, RGB LED. Thank you, and I'll see you next time.